so I am the 3D technical artist, and I'm working with Unreal Engine since UDK. So it's a pretty long road. And yeah, I started my journey when I was 9, and learning 3ds Max, creating levels for Duke Nukem 3D or mods for Warcraft 3. And for 9 years, I was technical art director at Illusion Ray Studio. And my greatest achievement was the game The Beast Inside, where I was one of the main creators. And yeah, it was a big success, and I hope that maybe someone here played that game. Yeah, so currently I am senior technical artist at Mountaintop studio, working with industry veterans from Riot, Blizzard, Respawn, Bungie, and Oculus. And yeah, so there's a lot of slides, and it's gonna be a little roller coaster, so for which I apologize. But I wanted to include as much as possible in this time. So yeah, so in this presentation, I want to focus more on the practical knowledge. I'm not going to go into much details like a low-level engine stuff. So first we discuss the profiling, then we're going to talk about the different threads, talk a little about the art pipeline. I will give you some reference and summarize everything in the end. So, okay, so think about optimization from the beginning of the project. And it might seem trivial, but from my experience, it's not always obvious. When creating a project, it's always worth thinking about optimization from the beginning. So, because when you know your limits, and you can approach different assets and different techniques in your game, so you know how the spec requirements are working in your game. Basically, if you know your limits and you know how the game works currently, you can also create some pipeline for content creation for the artists. And it's much easier to develop across the departments. For example, if we have sound designers in our team, they really wanted to work with your engine that works fine, that there is no hitches. So it could be very important for the other departments. And it's much easier to add content when you have your performance space, when you know that you can add additional feature, and it also gives you to access to the other platforms, for example, like mobile. So yeah, and the last access for alpha, beta tester, or investors could be very useful when you want to send your build to the investor, and it's always a good thing. And better optimization, of course, means bigger market. So always think about the consequences. From the beginning. Such a game are difficult to profile. There are many elements, and if you don't think about it, the main consequence is that there's going to be a negative impact. It's hard to profile game in the late state, and in many cases you need to delete a lot of stuff because they are not optimized in an early state. And yeah, and of course, when we are optimizing the game, it could create create more bugs. And what is also what is worth knowing, is that it's very important for the team that they know that there is a responsibility for outsourcing, and make sure that everyone in the team know the basic profiling process. And it's not only the technical artists and engineers, but also artists and sound engineers. They should know the basic profiling, so it's gonna be much easier for entire team. And it's also responsible of the leaders to learn to teach others. And last, engine will not optimize the game for you. There's a few tools where it could help you, but in general, you have to help the engine by yourself. So So to check the performance, I would suggest that never use the editor. There's a few cases when the editor have to be used because, for example, you cannot build the project. It's not working. But in general, when you want to profile the game, use the cooked build. Use the best cooked build is the test build. And of course, test the project on the target platform. For example, when you are targeting the mobile platform. And if you have to do this in the editor, play in the standalone, minimize the editor frame rate, turn off the frame rate, and vsync for your project. So the first question would be wherever I'm GPU or CPU bound. We can start with the basic stat unit command line, which shows the different threads and the length of the time it takes to render each frame. So we have in here the frame that shows the total number in milliseconds. This is our number that we could convert into the FPS, like 60,67 milliseconds is the same as 60 FPS. That's pretty important, but you should always look at the milliseconds, not at the FPS number. So the game, basically the game thread, it's all the gameplay operations, so everything that you have in the blueprints and C++ or any script language that you use is going to be here. The draw is a thread where the CPU where the CPU prepare the frame for the GPU. And of course, the last one is the GPU thread. All the calculations that need to be done on the graphic card. There is also a great command line stat unit graph, which show the same stat unit, but it's going to be on the graph, so it's much easier and better to find any hitches. Like when you're spawning the particles, you could see some hitches in your game, and that's a great way to finding it. So I know that I said that we're not gonna say too much about the theory, but it might be, the basic stuff that I believe that you should know about this. So basically, when we have those threads, the first one is the game. It's rendering the first frame, and then it's passing this frame to draw, and draw is passing the frame to GPU. Those threads are working in parallel. But what is important, when your game is very high, then the draw and GPU will be the same because they are waiting for the game. But for example, if the draw is the highest, the game could even prepare a few frames, but the GPU is going to wait for the draw. That's the most important to read the stat unit values correctly. So. So basically, when we have our minimal spec requirements for the game, for example, you could say our game needs to run on a switch and 30 FPS, and this is your target. So when you have your target and you profile the game, finding the bottlenecks, and when you meet those minimum requirements, there is another step that should be taken, and you should run the profiling through every week, every milestone, every new map, or any another new important feature in your game. The other cool way is to create an automatic way to profile the game. For example, you can create a sequence that is gonna walk through entire level and collect all the data into the traces, and then you could compare those data week by week, and you have the control over all the changes in your project. So I will talk a little bit about the tools, what you can use to profile the game. So the basic one are the command lines. So the stat unit, RTI, GPU, scene rendering are the common ones. And of course, there's a great tool called FPS chart that's gonna generate all the data that you can use in the spreadsheet. So that's a great way to compare those spreadsheets between different traces. And the most straightforward method is using show flags. So basically, you can just disable different features in your game and find those little bottlenecks, what is causing the issue. And yeah, and there's a few tools in the editor that you can use. The most important are, of course, the view modes, where you have shader complexity, light complexity, quad overdraw, and stationary light overlap. And the other one that I believe most of us know is the GPU visualizer that you can run using a simple shortcut. And maybe the GPU visualizer will not be the best to finding the amount of milliseconds because it's in the editor, but it's great to find specific object that causing the performance to drop. And okay, so there's a few another tools. So the Unreal frontend is a great tool that was introduced many years ago, and currently it's not developed, but it can enable it. It was disabled in 5.3. So basically, you can trace the game, and those traces could be open in session frontend. And then, for example, in the picture, you can see that there is a game thread, and there is all the functions, that took time, and there is even a number and percentage for every function for your game. And I would say that Epic currently developing Unreal Insight, and it's just the most important tool right now. So basically, it's very similar to the session frontend. You just need to make a trace, and you can even run this on the server, or you can create your own trace in the code, customize different channels, and even debug network traffic. One of the greatest tools that I would say it's even old, it's RenderDoc. It shows how the graphic card work, and all the passes, how it's from the inside and how it's working. You can look at the different draw calls and the gbuffer. So that's a great tool. You can even launch any application that you have on your drive, like a different game. So that's a great way to experiment. And more advanced tool, it's an NVIDIA Insight graphic. It's very similar to RenderDoc, but of course it's only work on the NVIDIA graphic cards. And yeah, so the first thread that I want to discuss is the game thread. So basically, it calculates all the game logic and transforms it on the CPU. So animation, object position, character movement, physics, and spawning and AI. So when we want to optimize the game thread, the first question is what it's ticking. So we need to optimize the tick. So every functionality that we are doing, every frame is the most expensive. And what is very important, every class that you create, it's gonna have start with tick enabled by default. I would say if you are not even doing any calculation on tick, you should disable this functionality. You can even do this in the project setting for your entire project. And what you can do is change tick interval. So many calculations that you are doing in your game could be done in some periods of time. You don't have to do them by frame. So it's very important to add tick intervals for this functionality that don't need to use it. So, so for example, you have an object that is very far away. You could change these intervals in runtime. It's very good way of optimizing the CPU. Of course, you can move tick code to C++. You are doing this in Blueprint. I will talk about this a little bit more later. And what you should also remember that the components also have a tick. So if you have a blueprint and you have a lot of components in this blueprint, every component have a tick. The most common one that is very expensive is a movement component. So for example, if you have an AI that is walking far away from the player, and maybe it's not even visible, you could change the interval, so update those AI only in some periods of time. And of course, based on the architecture of your game, you could use events and delegates instead of a tick. So it depends on the project, but that's the best way of dealing with some of the calculations that could be expensive for your project. And yeah, and we are talking about the tick. What is important to know is that the animation also are ticking every frame. So when you're having an animation grouping, they are updating every frame. And what good practice is to move this code to C++, of course, but you have to remember that you should use nodes that have only this lighting icon. There's going to be much more fast, and move the complicated math on events or notifiers, because many calculations shouldn't be done in the tick. You can make those calculations on events and only pass those values to the tick. And yeah, and of course you can change the animation frame rate based on the distance. I believe everybody know that many games, when you look at the characters in the distance, they have lower frame rate. And this is one of the way of doing that. Just change the frame rate and the updates based on the distance. And yeah, and don't use procedural animation in the animation blueprint. Try to use shader instead, for example. And another animation that it's very common is using timelines in the code. And I believe many indie studios are doing that. So timelines are not great because they always calculate every frame, and you don't have control ever over intervals. So never use a loop flag in the timelines. It's really hard to find that later. Use events to drive timelines. But in general, I would suggest just don't use timeline. Move the timeline logic to custom components. You can do that. And if you are animating some meshes on the scene, try to move those animations, for example, to skeletal mesh. But what is even better is move those animations to the pixel shader. So there's a great example. It's very common animation when you have a Fresnel effect on the body. And in most cases, you could use timeline for this, but it's much better just to use a few nodes where you just control the one parameter, and it's going to be much better for performance. And the best way is to move the animation to vertex shader. There is something called VAT, vertex animation texture. Basically, you can create any animation, for example, using Houdini, and saved all the translation into the texture, and Unreal can load that texture as an animation, and that's the best and cheapest way. Yeah, okay, so blueprints cost much more than C++, and the main reason is because there is a virtual machine that needs to translate those blueprints to C++ in runtime. So when you're translating when you change your code into C++, basically only making a change is a great win for performance. And the good practice also is not only moving the code to C++, but using the events, delegates, notifies instead of tick. For example, when you're calculating complicated math, move the animation to shader or skeletal mesh. And something that I would suggest is avoid using all actors of class. And there is a great speech about that, lessons learned from a year of Unreal Engine AAA development. It's a great speech about hard reference and those expensive nodes. And the last one, you could also try to use nativization method. It's a method where Unreal will generate the C++ code automatically during the cook. But it might not be the best way if your game is complicated. Yeah, but you can try that. So I'm not an expert when it comes to UI, but UI could be even more important than all those sticks calculation. It cannot be overlooked. It could be your culprit. So the good practice is just never use the bind function. And the bind function, there's a screen. I wish Unreal will never add this feature. And in the older version of Unreal, before Unreal Engine 5, the canvas was the basic panel for every UI. And that's not the best way of, that's not wise when it comes to performance. So use, for example, overlay instead of the canvas. And if you can, move all the logic to custom components. So it depends on the architecture, but in general, you should divide all the logic and the visual aspect of your game. So for example, if you have an icon on the compass, this icon don't need to be updated every frame. You can do this based on the distance, and it's gonna be almost the same. Of course, you shouldn't use the widget timeline animation. Of course you can, but they are expensive. There's a great library. It's a free library, UE Material Lab, where there is a bunch of material functions that you can use to create very custom, fancy animations. So using shaders instead is the best for any animation. And of course, you can move the UMG to Slate. So basically, it's a UI in C++. OK, so the next thread is the draw thread. And when we're speaking about the draw thread, we always should think about the draw calls. So the draw calls are very complicated topic, but in general, you should just remember this simple equation. Every draw calls equal mesh multiply materials. So as you can see in those stats, the number of draw calls are visible in those stats. And there is a few ways how we can optimize the draw calls. And the first one, there is not many information in the internet about it. It's auto-instancing. So basically, it was a feature that Unreal created for VR. So in documentation, in documentation of Epic, it's auto-instancing on Oculus, but it's working by default for every project. And basically, Unreal Engine automatically combines all the identical meshes with the same materials into one draw call. So as you can see in the picture from the render doc, there is a sphere, and this sphere is identical, so it's going to be combined into one draw call automatically using auto-instancing feature, and you will have only one draw call with 21 instances. So there's a few things that you need to remember when it comes to auto-instancing, because there's few cases auto-instancing will not work. So for example, if you use a vertex color on the scene, for example, if you painted an object, it will change its vertex buffer. So basically, it's going to be a unique object for auto-instancing, and painting object using vertex color will broke the auto-instancing feature, and it's going to be rendered as a separate draw call. So there's a few parameters in the static mesh that will prevent auto-instancing to work, like receive decal flag. Also, that's something that I discovered last year, was when you're using static light and you're baking all the object in the scene, every object that is using different light map is going to be packed in also as a separate instance. So change your light map sizes to the max value. It is 4K right now. OK, so there is a way. There is one cool feature that many people don't know. Is something called custom primitive data. So when you go to so basically when you want to change a color of an object, you will create a separate material instance. And separate materials means separate draw codes. And we really don't want it. So basically you can change your parameters into something that is called use custom primitive data. And then you can control this parameter in the details of the static mesh. And they will gonna be rendered as a single draw code. So that's a great tool, and you can create entire workflow based on that. So another tool to reduce the draw codes are instance static mesh and hierarchical instance static mesh. They are almost the same. The main difference is that the hierarchical instance static mesh they have LODs on all the non-nanite meshes. And this is a great way when you want to have a non-destructive workflow, when you want to edit your meshes, but they're gonna be packed into the draw code based on the number of the meshes and materials. So the biggest cons of using that tool is that they're not gonna be called per instance. So when you look at this picture where the camera is looking at the top, all the objects that are in the same hierarchical actor, they're gonna be rendered, even if they are not visible in the screen, because they are not called per instance. So this is something important to remember. So to create an object like that, you can create a component in the blueprint. You can also use merge actor tool. There's a batch functionality to do that. And the great way is, of course, create your custom tool, like some maybe volumes that will collect all the objects and create the HLOTs using editor utility widgets. There is also a tool called LOD, Outliner, that collect all the hierarchical, all the mesh. It collects all the meshes and create a hierarchical instance static mesh actor. But there is a great robust solution in Unreal Engine 5 called packed level actor. Basically, you can just select objects in the scene and change them into the packed level actor. They're gonna be hierarchical instance static mesh actor. So you can edit them and change them and repack them in any time. And for Unreal Engine 5, if you are using word partition, or if you are creating a game that is open world, I would suggest using HLOT batch that automatically create HLOT for every partition. And another tool that is, I believe everybody know about it, is the foliage tool. Is almost the same as hierarchical instances static mesh, but the main difference is that it's rendered as clusters. So basically, foliage are divided into different clusters, and those clusters are rendered in a draw code. So it's much better because you have occlusion on the object. So all the objects that are not visible will be called and based on the cluster settings. You can create foliage using, of course, foliage tool, procedural foliage tool, or create your own tool that, for example, could gather all the objects in the scene and change them into the foliage automatically. There is also a tool called landscape grass that is really great for, basically for the grass, because it's create a bigger cluster, it's more simplified, it's the fastest way for instance static mesh. And the last one that I wanted to talk about is the merge tool. And the biggest advantage of merging actors into one is that the draw codes equals material. So it will merge all the static mesh into one. And for example, in this case, in the picture, you have only 2 draw codes based on the material. Of course, the biggest cons is that those objects cannot be called per instance. And this is a destructive workflow, but you could create your own tool that will merge all the objects in the scene and unmerge them wherever you want. So that's a great tool And another few things that I want to cover are that important for the draw codes are, of course, VFX. If you have Niagara particles that have a lot of materials, a lot of meshes, all of those could have huge impact on the draw codes. And also decals, that every decals that you have in the scene that are separate draw codes. So you need to keep their numbers, and based on the platform that you are targeting, it should be the value that you choose that is good for your project and for the game, for the draw thread. And the last one, but not least, is the 3D imposter sprites. So basically, that's our 3D sprites that could be replaced in the mesh on the last LOD. So there's a great example. It's from the Hogwarts Legacy. Most of the objects that you can see in the picture are the imposters. They're not 3D meshes anymore. They're just sprites. But they did it in a great way. So you can do this by yourself using Imposter Baker. And the newest Unreal Engine is a plugin that could be enabled for any project. And yeah, and the next thread. So the next thread is the GPU. So it could be the biggest one. So I'm not going to cover all the passes. I only focus on the most important ones. So of course, you can use some profiling, the profiling tools that I mentioned before. And as you can see in the stat GPU screenshot, we have different passes that every pass takes some time. So basically, you need to understand some of them. And the first one is the prepass. So basically, the Unreal is rendering a Z-depth, and the Z-depth is used for occlusion. And the biggest and most important for the prepass is the number of triangles. So how we can reduce number of triangles. And first of all, you should use a statistic audit window. And in the audit window, you can see all the objects in the scene that are heavy, and they are the heaviest one. You can group them together based on the triangle count. And yeah, and of course you can visualize them using quad overview view mode. And if you wanted to reduce the number of triangles, of course you can do this in the 3D software, but there is a great tool in the static mesh settings. It's called reduction settings, and you can change the percentage triangle value for every static mesh. Of course, use LOD and imposters for the objects, and if you are using the DirectX 12, you could also try to use Nanite. Yeah, another very important pass is the base pass. Basically, it saves all the per pixel attributes into the GBuff buffer. It depends on the settings. In the forward shading, it works a little bit different. And the most important for this pass, it's not only the number of triangles or objects, but also the screen resolution. And for the screen resolution, if you are trying to find the bottleneck for your project, I would suggest using a simple command line and change your screen percentage to lower value, and it will give you the information about the, for example, the base pass, how it's heavy, and if this is help for your project. And yeah, so there's a great tool in Unreal Engine 5. So you can see those are the same pictures that are using screen percentage 61, but the one at the top is using a new anti-aliasing method, temporal super resolution. So you can try to use that method and change the screen resolution to 71. And basically, you will have almost the same quality, but it's going to be much better for the optimization if you have problem with the screen resolution. Of course, you can also use DLSS for newer graphic cards. And yeah, and another important pass another important thing that you can do for the base pass is the shader complexity. So basically, all the calculations that you have in the shader could impact the base pass. So it's very important to use switches to disable all the unused functionality that you have in your project, and avoid using most of the materials functions like procedural noises. So yeah, and my tip is that when you are using a power node, it could be very expensive when you are putting a lot of nodes into the power. That could be very heavy, so be careful with power node, and also with the tree-planar mapping. And because when you are using a tree-planar mapping, it will it's a triple sampling of each texture to make the UV to blend between all the axes. So if you don't need a blending between axes with tree-planar mapping, use a single sampling. Yeah, and it depends on the art pipeline that you have in the project, but try to not to use too many procedural techniques to generate details on the objects. And if you can, move all the complex math to HLSL. And there is a great feature called quality switch and feature level switch. So you can change your shader complexity based on the platform or based on the player settings. And if you can move the calculation from the pixel to vertex, and it's going to be much better for the optimization. And the last one is using something that is called dynamic branches. It's pretty complicated topic, but if you're using, yeah, you will need to grab more information from the internet, but basically you can create dynamic switches in your code, but try to use it wisely and don't put too many branches into dynamic branches. Yeah. And the next pass that is very important for the GPU is the translucency. And the translucency is a separate pass because all the transparent objects in the scene, they are rendered as a separate pass. They're using a forward shading because they are not sorted the same way. And something, of course, the most important is the number of pixels on the screen for the translucence object. And we could talk about the overdraw and shader complexity problem a little bit. And what you can do with the shader complexity is all that I said in the previous slides about the shader complexity. But for the translucence, you could also switch the lighting mode. This is the first thing that you should try. And basically, based on those settings, if you don't need, for example, dynamic lighting on your material, you could switch to volumetric non-directional. And try to avoid using surface forward shading because it's very complex. Yes, when you're creating any particles in your scene, and for the particles, I mean in most cases are fogs and smokes. So try to limit the lifetime and the sizes of those particles. It could affect the translucence very much. And also when you are creating and you have a translucent object, try to cut all the polygons to the minimal size so you don't have transparent values that are very, they're near zero. So you need to cut those polygons to the smallest number to reduce the number of pixels of translucent object on the screen. And try to, if you can, try to change the shader to mask. There is a great node called deter temporal array node. So basically it will take all the opacity value and deter those values into the mask. So the sphere on the blue sphere in the picture is a mask material. It's not transparent, and that's really cool. And the last pass, it's it's a light pass. I would say there is a few passes that affect the lighting, and I will try to talk only in general. I will not cover all the light passes. I will speak only in general. So the most important when you are trying to optimize the lights, it's trying to optimize the number of dynamic lights. And it depends if you are using only shadow light or you are using dynamic lights without shadows. There is a difference for the lighting passes. And what you can do when you have problem with light passes is, of course, minimize their number. But what is the best solution that it's seen from Unreal Engine 3 is using a static lighting. So you can bake all the lights in your scene into the light map, and for the Unreal Engine, all those lights they're not gonna be calculated. It's gonna cost 0. So that's a great way of optimizing the game, but it depends on the pipeline and your own type of your game. So what you could also do if you have to use dynamic light is to minimize the radius, and you could try to disable use inverse square falloff for your object. They're not gonna be physically accurate as before, but it's gonna be good for optimization, and minimize the number of assets that you have. Okay, we don't have much time, and I believe I just took too much time from some of the slides, but that's the last one. When you're creating a pipeline, try to use atlases and trims, and that might be the most important for your for your game. There is a great materials on the internet. I would suggest trying to find and see, for example, Oskar Świerat channel. So so I believe maybe you learned something from my presentation, and you are not like Michael from the MEM. And thank you.
Very much. And do you have any questions to our speaker? Please ask. It's right time to ask a question. Yeah, we have a hand. First hand. You're very brave.
Thank you for the great talk. I was wondering, because the most profiling tools are just working from PC, for example, the NVIDIA or the RenderDoc, and what about profiling on Android devices that was very versatile and for me?
I would say that you should use Unreal Insight, because you can just you can create the traces for any platform, and based on those traces, you could find anything. So, yeah, Unreal Insight is the best tool in creating traces.
And I was surprised about this dithering, because I was when I heard it, it seems like you need to both objects to be rendered, because there would be like the overdraw from the dithering. I was surprised.
Yeah. Is that the question? Sorry, maybe I didn't get it.
It was emotions.
Okay, thank you.
Yeah, thank you very much for your emotions, surprising and question. Have you any more questions to our speaker? Yes, of course.
So I have a question about optimizing performance for the huge open worlds. I think you briefly mentioned world partitioning. Are there any other, like, let's say, techniques in Unreal for optimizing like your game with a huge open world?
Yes, I would say that would be a separate speech. In the last slides, I have information that I didn't cover the words optimizing the open worlds game. And basically, the first and most important tool is batching the agelots. So you need to understand how the instancing and agelots are working. And also, I would say use packed level actor. So for example, I don't know, if you have an open world and you have a camp in your game, you can pack entire camp into one actor, and it's also going to be great. So yeah, H-load batches and packed level actors.
Okay, thank you.
If it's not enough, you can ask additional questions because we have time. Okay. Yes, please.
Yeah. So the techniques that you've mentioned, they were available like 10 years ago. It's cool and such. But what like the most recent groundbreaking optimization technique maybe you encountered? Like by yourself, like recently, like, wow, that's so cool. Like, I knew that, like all that thing, like 10 years from the past, right? But now we have this thing.
I would say it depends of your project, of course. But if you are using only the newest features, like Unreal Engine 5 and Nanite and tools like that, I would say still for open worlds, it's gonna be the word partition H-load batching. That was one of the features that was mind-blowing for me, and also level packed actors. So maybe those two. But in general, for most of the projects, it always depends. Every project is a little bit different, and there is nothing that I can say that this feature made everybody's life easier. So, yeah.
Right. Thanks.
Thank you for your question. We have time for more. Yeah.
Hi, thank you for the great talk. Well, my first questions might be a bit technical, but you mentioned that the number of draw calls is roughly number of meshes multiplied by the number of materials.
Yes.
Is it the same for the instance materials? Like if I use the same material but with different set of textures and parameters?
It's the same. Yes.
Okay. I see.
Yeah. It's because. When you're creating instance static meshes and you create they automatically, you can even see that every mesh that using a different material is going to be packed in a different actor, different ISM actor.
Okay, I see. The other question is about, you mentioned nativization of blueprints.
Yeah.
If I remember correctly, it was deprecated in Unreal Engine 5.
Yeah.
Are you aware of that?
I'm not sure about it. I would say that you can try that tool, but I personally don't have many experience with that because for more complicated projects, it's not working. Just write that. So maybe that's the reason they deprecated this in the newest. Yeah.
Okay, actually, because I remember the people from my team who tried to use it, they ended up developing our in-house solutions for that or doing it manually. It didn't work for them in the end.
So that's why I'm saying that you can use this for the more simple projects, yeah.
Okay, that's it. Thank you.
Thank you.
Thank you very much.